Applied functions. First question asks to express the radius r of a circle as a function of its area. Its area A. Also, find their domain. Now, when it says express the radius as a function of A, that means R should equal, and the only variables, if you do see a variable, should be A, minus 7 over A. This would be the radius as a function of A. That is, remember, whatever this is, if this equals 7, then R equals 7. If this equals 14, then R equals 14. R equals whatever the other side is. R equals whatever the right-hand side is. And to know the right-hand side, all you need to do is know what A is. So R is a function of A. Well, radius of a circle, area of a circle. Well, I know that A is equal to pi r squared. Let me solve for R. A over pi is r squared. So R is plus or minus the square root of A over pi. So why didn't I write the minus? Because the radius of a circle is never negative. Now, in terms of the domain, A must be positive. I guess it can be 0 if the radius is 0. The radius isn't a half, which would be that amount, or the radius isn't 1, which would give us that amount. The radius isn't 3, which would give us this amount. Sorry, the radius is not 3, which would give us this for the area. The radius is 0. The area of our point is 0. Okay, that's that problem. Now, suppose you were asked to express the area of a circle as a function of the circumference. Express the area A of a circle as a function of its circumference C. So ultimately I want A, and it should only be C, like maybe 3C minus 7 over pi. Well, we know that the area is pi r squared, but that has r in it. Circumference is 2 pi r. Oh, I can solve for r and then plug it in there. C divided by 2 pi is r. Just divide both sides by 2 pi to see that. So I know that A is equal to pi r squared. I'm just going to write r that way. R is C divided by 2 pi. Okay. Now, we'll talk about that formula in a moment. Now, this gives us pi times C squared over 2 squared pi squared. But this is just C squared over 4 pi, because 1 pi in the top kills off one of the 2 pi's in the bottom, leaving 1 pi in the bottom. Now, the circumference divided by the diameter is always pi. If you don't believe that, the circumference is 2 pi r, and the diameter is 2r, and I get pi. This is a fairly well-known property. But another way of saying diameter is 2r equals pi. I can swap those two. C over 2 pi is equal to r. That's another way to get it. That's a slick way of getting that r is c over 2 pi. Okay. You can always switch those two and you get c over pi is equal to d, which is 2r, and then just put the 2 back. However you get it, we have a as the function of the circumference. Let me just change the way I wrote a. A is only in terms of c. Okay, that is, if I tell you the circumference of a circle is 7 pi. What's a? Well, it's c squared over 4 pi, which is 7 squared pi squared over 4 pi, which is 49 over 4 pi. It is 12¼ pi. And all I knew was the circumference. Suppose you want to build a rectangular dog pen, and the perimeter is 20 feet. All you have is 20 feet of fencing. Oh, okay. All you have is 20 feet of fencing, and we want to express the area A as a function of the length x. Express the area A as a function of the length x. So the length is x. Let us call that y. We know that the area is xy, but this has x and y. This is the width, this is the length. Well, I know that y plus x is, well, the perimeter is 20, so that must be 10. This is 10, and of course, that's the other 10. So I can get rid of y by bringing x to the other side. Y is 10 minus x. So A is x times y. Maybe you can leave it like that. You can distribute out. But more importantly, A is this formula, and it is in terms of just the length. You plug in a length, it will give you the area. It already has the y built in. It has the length, and the width is y, but it's built in here. Right there, that's y. That's x times y. Fair enough. It looks like we only see x's, but that's because y depends on x. If I make this longer, then y needs to be shorter. If I make x shorter, y needs to be longer. Y is a function of x itself. Okay, and here is the answer. suppose you have an open box. And open rectangular box, and it has a given volume with a volume of, say, 12 cubic feet, has a square base. It has a square base. So we want to express the surface area of the box as a function of the length, as a function of the length x of a side of the base. Okay, so here is the square base, and it has some height. Okay, this is x, so this is length, that's width, and that's height. Okay, now so now we have the bottom, and then we have the four sides. Okay, no top. Now the surface area, well, the bottom is x times x. X times x. Now this side is x times h. So plus xh. But you know what? This side here is also xh. It's x times h. The side in the back is also x times the height of h. The left side, it's x. All four sides on the base is x times the height, which is still h. So you have four of those. And you're like, oh my, s right now is a function of x and h. So somehow we need to get rid of h. Well, the volume on one hand is length times width times the height. On the other hand, it's 12. So x squared h is 12. H depends on x. You make x larger, you have to multiply it by a smaller number to get 12. That is, h is 12 over x squared. So this becomes x times x plus 4x times 12 over x squared. We get x squared plus 4 times 12 is 48, but x over x squared is just x on the bottom. So now we have s just as a function of one side of its base, its square base. Okay? You plug in x, it will give you what this equals. It will give you what that equals, because these two horizontal lines tell me that h is 12 over x squared, and I can replace that x with 12 over x squared. I hope you're seeing a pattern here. There is something called a Norman window, like the window in a house. This part that I'm about to draw isn't part of it, but just to emphasize, it is rectangular shape with a semicircle on top. Okay, so a Norman window will look Exactly like that. Okay? Half circle on top. The rest is a rectangle. And again, they call this a Norman window. I guess they named it after Norman. Okay. Now, they tell you the following. If the perimeter of the Norman window is 30 feet, they want us to express the area A of the window as a function of its width, x, and that's x, the base. Okay. So now the question is, what is the perimeter? So this is x and maybe that's y. So we have x, we have plus y, plus another y, plus the semicircle. So it's the circumference over 2. Now the circumference is 2 pi times r. The circumference of the whole circle is 2 pi r. I'm dividing it by 2 because there's only half a circle. Now, remember the radius is half the diameter. So, if we draw this just to make life easier, that's the radius. The whole thing is the diameter. The radius is half of x, x over 2. Coincidentally, those x's cancel out. Those 2's can cancel out. So we have p is x plus 2y plus pi x over 2. If I think of this x as 2x over 2, now I could say that this plus this all over 2 is 2 plus pi, 2 plus pi x over 2 plus 2y equals 20. Okay, equals 20. Now, maybe I shouldn't have done that yet. Maybe I should have said, well, the area is going to be this piece, well, that's xy, plus the area of the semicircle. Well, the area of the circle is pi times r squared. Well, we divide it by 2. And once again, r is x over 2. So we have xy plus pi x squared over 2 squared, which is 4, over that 2, which is over 8. So that's the area. But it has x and y's. Now I need to get rid of y. So I come and I do this work. And I realize that I can solve for y. 2y is equal to 20, bring this over, minus 2 plus pi x over 2. That's 2y. Over 2 gives me y. So 20 over 2 is 10, minus this over 2 will be 2 plus pi over 4 x's. Okay, so I am done now. A is equal to x times pi minus 2 plus pi over 4 x's. That's xy plus pi x squared over 8. Okay? So now a is a function of just x, which is exactly what they asked us to do. Find a, or write a as a function of x. But we'll go a little bit further. We have distributing the x. We have 10x minus 2 plus pi over 4 x squared plus some other x squares, pi x squared over 8. So now, let's see. We have 10x minus 2 over 4. Let's break up this sum. We have 2 over 4, which is a half x squared, minus pi over 4 x squared. You know, let's just get everything to be over the same denominator. I'm going to multiply the bottom by 2 and the top by 2. So it's going to be 4 plus 2 pi over 8 x squared plus pi over 8x squared. I mean, basically we get have pi over 8, and we are taking away 4 over 8, and we're taking away 2 pi over 8 x squares. Just can't get a handle on a nice way of writing that. Well, plus. We can combine those. 2 pi over 8. So it's minus pi over 8 minus 4 over 8 times x. One last thing. Factor out the minus sign. We get 10x squared minus pi plus 4 over 8 x's. I have a, the area of that Norman window, just as a function of x. You tell me x, assuming that the perimeter is 20. Given that the perimeter is 20, if you tell me x, you like x is 4, I can give you the area. If you make x a little bit more less than 4, a little bit more narrow, I guess it'll be taller than, and I'll get another area. You let x be 8, twice as long, it's not going to be as tall. And I get another area. My area just depends on x and the perimeter. This completes this section on applied functions.